Hello everyone, welcome to this video. I am Akshay Jain and this is the 12th video of data science series. In this video we are going to discuss part 2 of assignment, which is model evaluation and validation. In this part we are going to discuss question 3rd and 4th, which focuses on two critical aspects of machine learning: how to properly split and validate our data and how to evaluate classification models using various metrics. So let's begin. Uh, Question third is about data splitting and cross validation. Asks us to explain the purpose of training, test, and validation sets in machine learning, and to understand cross validation and how it differs from simple train validation test split. Uh, Purpose of data set splitting. Let me explain why we split our data into three separate sets. When bulking machine learning models, we need to evaluate them on data they have never seen before. This is why we divide our data set into three parts. First, the training set, which typically comprises 60 to 70% of our data. This is used to actually train the model to fit the parameters and learn the underlying patterns. Second, the validation set, which is about 15 to 20% of our data, which we use this to tune hyperparameters, things like learning rate or memorization strength, and to detect if our model is overfitting. Third, the test set, which is the remaining 15 to 20%. This is completely held out and only used for final evaluation to give us an unbiased estimate for our Twitter model's performance on completely unseen data. By splitting our data, this way we can build models that actually generalize well to real world data rather than just memorizing the training examples. Cross validation. Now, cross validation is a more sophisticated approach than simple train test splitting. The idea is to use all our data multiple times for more robust evaluation. With k-fold cross-validation, we divide our data into k-folds, typically 5 or 10 equal parts. Then we train k different models. For each model, we use one fold as the validation set and the remaining k folds as training data. We repeat this process k times. So each fold gets a turn as the validation set. After training all k models, we average their performance scores. This gives us a much more stable and reliable estimate of our model's performance compared to a single train test split. The advantage, the advantage is that we are using all our data for both training and validation rather than permanently setting aside data that never gets trained on. Let's see the comparison between simple split and cross validation. So what's the difference here? With a simple train validation test split, each each piece of data is used exactly once. The approach is fast and simple, but it can give biased estimates because we are only evaluating on one specific subset of the data. If that success if that subset happens to be easier or harder than average, our estimates could be misleading. Cross validation, on the other hand, uses all data multiple times. This better utilizes limited data sets and provides more stable, reliable performance estimates. The trade-off is that it's computationally more expensive since we have to train multiple models for limited data sets or when we need robust estimates. Cross validation is strongly recommended. Let's see the